Elizabeth mentioned, I'm going to give a presentation on a little bit of the basics of climate solutions and what we call drawdown, which I'll talk about in a minute, and a little bit of the kind of science we all need to understand to figure out what the solutions to climate change are. We've heard so much about the problems of climate change. Now it's time to roll up our sleeves and get to work on solutions. Should have been doing that for decades, in fact. But we need to learn a little bit more before we can do that in a most effective way. So that's what we're going to try to do today. I know some folks have already asked, will this seminar be available later? We are recording it. We will make it available if you want. We also give it live at multiple times, multiple time zones to catch people in different parts of the world. And I'll certainly be doing that again. And just for your information, we're going to actually professionally record another version of this. It's a little bit longer, but sliced into like 15-minute chunks, make it a little more watchable. And that will be available towards the end of the year. So stay tuned for that as well. But anyway, so you'll see plenty of this stuff if you want. So let me go ahead and share my screen and get the presentation up and going. Okay, here we go. So today we're going to talk about climate solutions and a little bit about the science we need to understand to be good at solving climate change and what do we do moving forward. But before we talk about moving forward, sometimes it's useful to look back and figure out how did we get here in the first place? Because human beings have been on this planet an awfully long time. Our ancient ancestors, kind of the things that eventually would evolve into Homo sapiens, something like us has been on this planet for like, I don't know, 6 million years roughly. And during almost all that time, we've had some impact on our surrounding environment around us, nearby in the local area. But only recently did we have a tremendous global impact on entire planetary systems, just an extraordinary explosion of our footprint on the environment. And most of that happened in the last 50 years or so. And most of this happened basically because of a few basic things. One is there's just a lot more of us in the world today. In the last 50 years, our population has grown enormously. We've also become more urban and more concentrated as a species. For the first time in history, humans, more than half of us, live in a city. And that wasn't true for the previous 6 million years. And also our economic activity and use of technology and resources has also grown hugely in the last 5 decades. And just to put this in perspective, in the last 50 years, our population more than doubled. The economy grew between 5 and 6-fold. Our use of food tripled during that time, our use of water roughly doubled, and our consumption of fossil fuels almost tripled in just 50 years. Think about that for a second. In the last 50 years, we've changed more than all previous human evolution and human history combined. The last 50 years changed more than the last 6 million years of human existence. And that last 50 years has caused us to disrupt entire planetary systems, not just a local environmental change, but now global systemic changes everywhere. Some of those changes are really obvious to us. We can see them, we can go out and walk around in them, we don't have to argue about them, we know they're happening. For example, we've been clearing forest, mainly for new agricultural land. This is a picture of part of the Amazon rainforest in the 1970s. And we went back and took the same picture again with a different satellite around 2003, seeing huge amounts of clearing, even in the most remote forest on Earth, primarily to grow more animal feed. This is soybean fields here. And that soybean product is being shipped mainly to China as feed for pigs. As China becomes wealthier, they're also consuming more meat, and those animals have to eat something. So soybean production in the Amazon, feeding pigs in China, is kind of a feature of our new globalized world. And because of all the pressures on rainforest over the last few decades and centuries, we've already lost almost 1/3 of the world's tropical forest cover, and we're losing a lot more every day. We've also changed the nature of water on Earth. There's still the same amount of water on Earth there was for the last few billion years. The same number of water molecules are somewhere, either in the ocean, the atmosphere, or in a lake or a stream or whatever. But we humans have used fresh water, which is very rare, in the places we need it at most. And we've had big consequences on the water cycle as a result. For example, this is a picture of the Aral Sea, one of the world's largest inland seas, at least it used to be, in the former Soviet Union in Central Asia. But the Soviet Union actually diverted the 2 rivers that fed the Aral Sea and filled it with water every year. They diverted those 2 rivers and used it to irrigate the deserts of Kazakhstan to grow cotton. And this is what it looks like today. We've literally erased one of the largest geographic features of Central Asia. And this kind of phenomena of collapsing water resources is not unique to Central Asia. It's happening in California, the Colorado River, the Agawa Aquifer, all just in the United States. It's happening in Iran, it's happening in North Africa, it's happening in Europe, it's happening everywhere. And so water resources are collapsing around the world too, another very visible sign of our kind of global environmental impact. So we've seen changes in land, we've changes in water and so on, but the one that's we're going to be focusing on now is changes to the sky, changes to the atmosphere itself and its climate. Now, we've known about this for a very long time, it turns out, that when we change the composition of our atmosphere, introducing more of these so-called greenhouse gases, which we've been doing for a while now, this will warm the planet. This is not up for any scientific debate at all. We've known this for a very long time. Starting in the 1850s or so, we began to increase the levels of greenhouse gases, one of which is carbon dioxide, or CO2. And since that time, CO2 levels have risen about 50% above what had been seen in the mid-19th century. In fact, it's higher now than it's been in the last 3 to 5 million years. What we're seeing now hasn't happened for a long, long, long geologic time. As a consequence of building up more of these greenhouse gases, the planet is warmed, roughly about 1 degree Celsius. And we can see if we overlay the temperature change with the CO2 changes, they line up pretty remarkably. It's funny though that we start this graph back in the 1850s because that's when science first realized that increasing the levels of CO2 could warm the planet. When I was in graduate school, I always learned that it was discovered around the 1860s by a guy named Tyndall from the United Kingdom. But it turns out, and the history books had not included this for far too long, it was actually an American woman named Eunice Foote, F-O-O-T-E, who actually first published a paper showing that increasing CO2 could warm the planet back in the mid-1850s, before anyone else. But as a woman scientist, her work was largely kind of set aside and ignored for far too long. Credit was given to other people in the meantime, and we've forgotten all about her. There's still not even a surviving photograph or painting of her today. We don't even know what she looked like. But I want to make sure we stop today and remember her contributions, not only to science, but she was also an early leader in the American suffrage movement to help give women the vote in the United States. So remember Eunice Foote, she's been ignored for far too long and deserves the credit, all the credit we can give her today. But here we have climate change. We know it's real. There's no debate about the basic science. The question now is, what do we do about it? This is an incredible challenge to be sure, because as our climate changes, so do many other things, like our water, our ability to grow food, how sea levels will rise and maybe inundate our cities and coastlines, how ecosystems work, how all wildlife on this planet works. Our health, our economy, our security are intricately connected to climate. And if that changes, then so will everything we depend on. So that's an incredible challenge. But let me stop you right here and tell you, just cutting to the chase, it is not hopeless. If people tell you now it's too late to tackle climate change, or we might as well give up now, they're wrong. They're just as wrong as the people who denied that climate change existed. Between denying climate change and being a doomist about climate change and just giving up hope, both of those things are completely wrong. We have to find a middle ground where we roll up our sleeves and get to work and address a problem because we can. We can still build the future we want. The future isn't written yet. We get to decide what it is, and we can make it a good one. And addressing climate change will be essential for us to have a good future. Like I said, all these things we depend on, our water, our ecosystems, our food, our security, our health, our economy, depend on a stable climate that we've had for thousands of years. So if we want a better future, we have to address climate change, because if we don't, a climate change running out of control could disrupt everything we care about. Equity, justice, prosperity, resilience, culture, all of these things we care about could be made worse if we don't address climate change. So climate change is essential to a good future, and the good news is we can still address it. That's what we do at Project Drawdown. We're a scientific organization that studies climate solutions, but instead of just writing reports for other scientists, we share them with you and everybody around the world. as a public resource to the planet around climate solutions. But why do we use this word drawdown? Why do we even refer to that? Well, drawdown refers to a moment in time that we are striving for. Let me wind back the tape a little bit. Here's a chart showing the levels of all greenhouse gases, CO2, methane, and a bunch of others we'll talk about later, starting in the mid-18th century and going forward to today. They've been rising dramatically since then. So here we are at the end of that curve. What's next? Well, we could continue to elevate those levels of CO2 and other greenhouse gases. And if we do, if that just keeps rising, so will the temperatures. As that curve goes up, so do the temperatures of our planet and disruptions to our weather systems and our whole ecosystem. But we don't have to do that. We don't have to have a bad thing get worse and get out of control. Instead, we can go and bend the curve. We've been hearing that phrase a lot lately referring to a pandemic, but it's the same kind of idea with climate change. We have one track, which is a lot more diseases, or we could do smart things like wear masks and social distance and be careful and bend the curve on a pandemic. Same thing with climate change. We have one choice is disaster, or the other choice is we get smart and we bend the curve and we make it better. So when we bend the curve, we eventually will hit this point, that little blue dot. That is the moment of drawdown. It's the moment when greenhouse gases stop climbing, they stabilize, and then we begin to draw them back down again. So drawdown is a moment in time in the future when greenhouse gases stop climbing and they start to steadily decline. And that's the minute we stop climate change from getting worse. At Project Drawdown, that's what we're all about. Our mission is to help the world achieve drawdown, to get there as quickly, safely, and equitably as possible. But to do that, we first have to understand what we're doing and what the problem is and what the science tells us about what we need to do next. So here's the basic problem. There are a variety of so-called greenhouse gases that let solar radiation, the sun's heat, go right through the atmosphere and warm the Earth's surface. You know about that. The Earth then radiates back to the universe in the infrared wavelengths, and some gases absorb infrared radiation and re-radiate it back to the Earth's surface, warming the surface of the planet. That's the so-called greenhouse effect. But if we increase the level of key greenhouse gases, including carbon dioxide, methane, nitrous oxide, and a few others, we'll make the planet warmer. There's just no way around it. Well, that's exactly what we've been doing. We've been elevating the levels of three crucial greenhouse gases over the last 250 years, and especially in the last 50. There's another category of greenhouse gases I'll mention later called fluorinated gases. They're also increasing. We just don't have as long a historical record of those. Now, where do they come from? Now, usually you're told that greenhouse gases all come from fossil fuels. It's burning coal and oil and gas. And if we just got rid of fossil fuels, we solve climate change. Well, if you say that, you're about 62% correct. That about 62% of the warming being caused by human activity today and greenhouse gas increases, when we level this all out on an equal playing field, about 62% of the warming we see now is being caused by the combustion of fossil fuels. So getting rid of fossil fuels will take out that part of the wedge. But there are other things that add to climate change as well, and we have to address these too. For example, CO2 is also released by other human activities besides burning coal and oil and gas. For example, making cement and some industrial processes chemically releases CO2 out of the air, into the air, I should say, rather than burning something. It's just simple chemistry. When concrete is curing, it releases CO2 into the atmosphere. Another thing that releases CO2 into the atmosphere is deforestation. When we cut down and burn, especially rainforests, for example, we are burning carbon that's alive in trees. And it's very similar to burning carbon that's dead in coal. The atmosphere doesn't care. You're burning carbon either way. Both produce carbon dioxide. So that green wedge is CO2 contributed from deforestation and other kinds of land use. So that's important. Then we get into other gases like methane or CH4. Methane is also known as natural gas. Some of the methane we're adding to the atmosphere, about a third of that wedge, comes from fracking, comes from coal mines and natural gas pipelines that are leaking. So that's kind of industrial activities, usually tied to our production of energy. The other 2/3 of the methane, though, we get in the atmosphere is caused by agriculture, primarily from cattle and a little bit from rice fields. My dog is causing this bit. Will you stop it? Sorry. That's my buddy Penny over in the corner here. You might see her. She's digging into the chair, causing a ruckus. We're all working in new ways this way. Anyway, about 2/3 of the methane going into the atmosphere comes from agriculture, primarily from cattle and sheep, and about 1/3 from fracking and from industry. So it turns out industry and agriculture are going to be really important to this one. Then we have another gas called nitrous oxide, which primarily about more than half of it comes from agriculture. It comes from overusing fertilizers and manure on farm fields, things that are rich in nitrogen. And when we use too much nitrogen on a farm, sometimes under the right conditions, it combines with oxygen and forms N2O and becomes a gas that leaves into the atmosphere, a very potent greenhouse gas. Some of it also comes from industry, but a lot of this comes from the agricultural sector, overusing fertilizers and manure. The last little bit is what we call fluorinated gases, or these so-called F gases. These are a weird set of chemicals that have very interesting chemical properties, but they're really useful. It turns out they make excellent insulators and refrigerants. We used to use something called chlorofluorocarbons, or CFCs, which is one of those kind of F gases, and we discovered that those were harming the ozone layer way up high in the upper atmosphere. We got rid of those for the most part and replaced them with hydrofluorocarbons, or HFCs, that don't hurt the ozone layer in the upper atmosphere, which is great. The problem is CFCs and HFCs turn out to be a major greenhouse gas. They trap heat and cause more climate change. There are a couple other chemicals in this family. One's called sulfohexafluorine, or SF6. You might hear about that if you ever work with transformers or utility lines. It's a really good insulator that people use. Anyway, those F gases, they contribute about 2% of today's climate change. The problem is that number could quadruple in the coming decades as more and more people buy air conditioners and refrigerators and freezers, especially in newly wealthy countries where people are buying their first air conditioners, often in places that have no regulations. So we got to check F gases too. The point of this little pie chart here is that we've got to tackle energy, materials, and land use and agriculture in order to tackle climate change, because that's where those gases come from. It's not just fossil fuels. That's the biggest part of it, but it's not the only part. And we've got to look across the whole board here of exotic materials, agriculture, land use, and the energy sectors. So that's kind of where the gases all come from a chemistry point of view. But I'm going to show you some other stuff here about where the gases come from and where they go from kind of a more sectoral point of view, which is kind of interesting. So here's a picture of the atmosphere. Imagine the atmosphere is like a big box in the sky. Actually, maybe you can even think of it like a bathtub, where you fill it up from the faucet, but you can empty it from the drain. You can both add and subtract things from the atmosphere. You can put them in and you can take them out. So we're going to show you this a little bit. The atmosphere can have sources of greenhouse gases. These are the major sources of today's greenhouse gases, now re-estimated in terms of their economic activity. We'll go through this in more detail, but you see electricity and food and industry and transportation, the things that we do that release greenhouse gases into the air. Well, let's say we put 100 units of greenhouse gases into the air. Guess what? Not all of them stay there. It turns out that nature does us a very big favor and removes a little over 40% of this greenhouse gas burden. A big chunk of it is taken up by land, primarily forest, by unmanaged forest, just nature doing its thing, and another big chunk by the oceans. And it leaves behind a little less than 60% of the greenhouse gases in the atmosphere, building up year over year, causing more climate change. This little picture, we call it the rainbow diagram in Drawdown. This is probably the most important picture you need to look at to understand what's going on with greenhouse gases and climate change. The left-hand side is us. That's humans dumping pollution into the sky, and it's causing more climate change. On the right, at least for now, nature's doing us a huge favor and removing about 40% of that pollution. That's fantastic. Otherwise, climate change would be a lot worse than it is already. So we can look at both sides of this equation. How do we lower the additions of greenhouse gas pollution? How do we lower the faucet, if you will, going into the atmosphere? But also maybe how can we help out nature remove some of these greenhouse gases, maybe even more than we're doing today? So to achieve drawdown, to get to that point where we stop climate change, we can do two things. Here's today's picture. We're putting in a lot more pollution than nature can take out, and so the greenhouse gas levels are building up. But what if we started working on the sources of the pollution? We started to dial them down to zero. We replace the way we make electricity. We change the way we make food and how we do industry and how we do transportation, all that. If we can bring those down to zero and we help maintain nature's capacity to help remove some of these greenhouse gases, we can then bend the curve and remove more greenhouse gases than we put in. We can empty the atmosphere of pollution and restore it back to something like normal in the long run. But for now, we can just stop climate change before it gets any worse. So when we think about climate change, we have to think about the sources of pollution. That's the place to focus most of our attention, as well as this removal mechanism, which we call sinks. That's just a fancy word for removal. So sources and sinks turn out to be the big crucial elements of addressing climate change, and we're going to need them all. So when we think about the solutions to climate change, first rule is stop the pollution where it begins. Start it from the beginning. It's a lot easier to prevent pollution than to try to remove it from the atmosphere later. So let's start with reducing the emissions of greenhouse gases and bring them down to zero over the coming decades. So this is this left-hand side of the diagram. Well, where do we act? Where do we go? Well, it turns out these are numbers for the whole globe. If we looked at them country by country, they would vary a lot between, let's say, the United States and Australia and China or Finland or New Zealand. All of these countries would look very different, but the global picture looks something like this. About a quarter of climate change greenhouse gas problem comes from electricity. That's burning coal and oil and natural gas, primarily coal and gas, to make electricity. Okay, we already know about that one, and we're going to fix that. Another quarter of climate change, which people are very surprised to see how big it is from agriculture and the food sector and land use. Basically, making electricity and making food together is about half of what causes climate change today. Those are the two biggest things we need to work on. Then we have the entire industrial sector, making everything we use and disposing of it. We have transport, moving stuff around. We have buildings, at least what buildings themselves emit. Of course, buildings consume electricity and they have industries happening within them, but this is what buildings release within the building itself, from a furnace, a hot water heater, a boiler, whatever. And then everything else, the remaining 10%, a lot of which is actually refining oil and natural gas and using it to make other things. But the first 5 sectors, electricity, food, industry, transportation, and buildings, are 90% of climate change, or just those 5 things. So let's focus on them. Let's take a look at those 5 big areas. Electricity, quarter of the global climate problem. Well, electricity is produced again by burning coal and natural gas for the most part, and it's used in major industry settings as well as in buildings. Those are the main uses of electricity. We send about half of it to our buildings, about half to industry, and a couple other things. So we can change both how we make electricity, the supply of electricity, but we can also change the demand for electricity in buildings and industry. So we can both be more efficient with our use of electricity and reduce the overall production need, and we can make it better and greener with renewable energy. But the first thing we've done at Project Drawdown is we always start by looking at efficiency, because you can do that today. You don't need to build a new power plant. You don't need a solar panel. You don't need a windmill. You just need to be more efficient. So we've evaluated a whole bunch of efficiency measures that can reduce the global demands for electricity. And I'll show you some of the numbers for that later. A lot of them are in buildings, but some of them can also be in industrial processes. lots and lots of ways we can be less wasteful with electricity, even if it's still using coal to make it. We can maybe cut the demand in half if we got more efficient. But then in parallel, we can also make electricity from non-carbon emitting technologies. For example, solar energy or wind or hydropower. Ocean power is pretty interesting. Geothermal, biomass, nuclear. We can use waste and turn that into electricity from landfills, methane capture, and so on. And when we look at all the solutions to climate change, we've evaluated the ones here. What we're showing here is different solutions in the electricity sector that can help us with climate change, drawn as little circles. Here, each circle, the size of the circle is proportional to the size of the solution. So the bigger the circle, the bigger the impact it can have on addressing climate change. Really good. Some circles actually have two circles within them, kind of an inner one and an outer one. That represents a range of what we think are kind of possible ranges over the next 30 years of what that solution could look like. So it's kind of a large error bar, if you will, kind of a range of numbers. So these are the electricity solutions, enhancing the efficiency of what we use today and then shifting production to greener, low carbon or zero carbon electricity tomorrow. We can do all of that. In the food sector, another quarter of climate change, about equal to electricity. We also have to address climate change as well. And it's kind of surprising how big this number is. Food is a huge contributor to climate change, but people sometimes get it wrong on what within the food system are the big culprits. Sometimes we hear about food miles, that we ship food from one part of the world to the other. Actually, that doesn't matter that much. All the energy used in moving food around the planet is actually pretty small. And sometimes it's not the distance we move food, it's how we moved it. Was it in a truck or a ship, airplane, a train, all that. It's not food miles. It's not organic either, or conventional. That doesn't matter either that much. Or GMOs, that doesn't matter much either. It turns out the big contributors to the food emissions for climate change are first deforestation, burning down forests to create new agricultural lands. Especially today, that's happening in the tropics, mostly in the Amazon and in Indonesia. In those areas, primarily this land is being burned down to make way for cattle and soybeans as animal feed. Those soybeans are not being used as plant-based diets. This is animals and animal feed. So that's why animals are so important. And the third would be palm oil, which is another important ingredient in the global deforestation issue. So it's animals, animal feed, and palm oil are the biggest drivers of deforestation. Then we have methane, which comes from animals and a little bit from rice fields. The animals, again, are mostly cows and cattle, so it's beef and dairy production for the most part. We'll talk about this later. You're going to hear a lot of kind of crazy stuff about regenerative agriculture, that methane doesn't matter because we'll just absorb it in the soil somewhere else. That's not really true. The methane emitted by our livestock and dairy operations is huge. It is a real massive climate problem, and we have to address it. We're never going to get rid of all meat, but dialing it down a lot could help, and then growing it better, which we'll talk about later through what's called regenerative agriculture, can help too. We need to look at both aspects of that, reducing the demand for these products and growing them better. Then third is nitrous oxide. That's kind of overusing fertilizers and manure. Again, too much nitrogen out on the farm field can turn into N2O into the atmosphere. So the big drivers of how the food system causes problems with climate change are deforestation for cows, for animal feed, and for palm oil, pretty much. Then we have methane, mostly from cattle and other livestock and dairy operations. And then we have nitrous oxide for too much fertilizers. Everything else is the other 5%. So when we think about this, we again, just like electricity, we can be more efficient with the food system we have today. And even as we learn to grow food differently, we can today do things like reduce food waste. It turns out about a third of all the food grown on the planet today is never even eaten. In rich countries, we tend to throw it away near us, the consumer, but in poorer countries, it tends to be lost closer to the farmer, between getting to the farmer's field to the marketplace. So we lose not only the food, the farmer loses their income, which is a kind of a double tragedy. So if there are ways we could reduce food waste, again, it's a whopping third of all the food produced, we could cut down a third of greenhouse gases, a third of the land use, a third of the biodiversity and water impacts. So this is one of the most crucial issues facing the world today in the environment is food waste, a really important area to focus on. Another area, because I mentioned how important animal agriculture is to climate change, but to everything else. Of all the land used in the world to farm, 75% of it is used to grow either meat or the feed we give to meat animals. So 75% of all the farmland is for animal agriculture, and a lot of our climate change emissions also tied to animal products. So reducing the demand on animal products could help too. Now that doesn't mean everybody becomes vegan. There are a lot of folks in the world who benefit from some animal nutrition, no problem. But we could dial it down and maybe replace some of our diets with more plant-based diets. Would take a lot of the environmental pressure off the meat system on the environment. So again, this is the efficiency part. Reducing waste and a more plant-rich diet would help a lot. Then we can protect ecosystems that are currently being burned down, especially tropical rainforest, but also grasslands and peatlands and other areas are being cleared for new farmland. If we don't need to do that and we protect those farmlands, they can continue to hold carbon and maybe even absorb some more. And then finally, we can grow food better. We can be more efficient with it, we can protect our ecosystems, and then we farm in more regenerative or more kind of environmentally friendly practices. You're going to hear a lot about regenerative agriculture in the next few years, which is kind of like organic, but better. It's not only reducing the harm to the environment, it's actually undoing some of the harm we've caused before and restoring, kind of regenerating soils and ecosystems and watersheds back to a healthier place, which is fantastic. So when we put all this together, we see the biggest solutions, though, in the food sector tend to be diets and food waste, then protecting ecosystems from being cleared further, peatlands and forest especially, and then farming better, managing our nutrients and our tilling of soil and cover cropping and regenerative cropping systems. All of those things could help a lot. So that's electricity and food. We'll go through the next three sectors a lot more quickly because they kind of follow the same pattern. Let's get more efficient and let's find a new way to make things. In industry, we have to think about a whole suite of topics. For example, how we make metals, especially steel, cement, which I mentioned before, some of our chemical processes, and also plastics. Plastics is about 1 to 1.5% of climate change is caused by making of, using, and disposing of plastics. Sometimes you hear it's a bigger contributor to climate change. It's really not. It's about 1.5%, but every percent matters. So we should tackle that too. And plastic has a much bigger impact in other areas as well, including ocean pollution, habitat destruction, and so on. So that's a topic we really need to think about. So we can be improving our materials. We're going to focus here on things like cement and plastics. We can tackle these so-called refrigerants that were used in air conditioners, freezers, refrigerators, and so on, those hydrofluorocarbons. Make sure that we're making them better. Maybe we switch to new materials that don't add to greenhouse gas burdens. We could also get smarter with our waste and use it again as a material or maybe as a source of energy. So we've looked at a few different industrial solutions. We're adding a lot more at Project Drawdown, but these are the ones we've evaluated already. And we see a lot of them matter quite a bit, especially the refrigerants, which is one that people don't usually think about. Then we get into transportation. Globally, about 14% of climate change is caused by our transportation today. And most of that is actually on road transportation. 10 of that 14% are cars and trucks, basically. Flying is a little less than 2%. It's like 1.8%. And everything else is the remaining 2%. Flying sometimes gets people kind of riled up. Flying is less than 2% of climate change, period. You're going to hear people multiply it by other things called radiative forcing and try to make it sound like it's 6% or 10%. It's not. It's 2%. It does have other impacts because when a plane flies in the air, it leaves behind contrails of basically condensed water vapor. Essentially, they're clouds, just made out of water vapor. So do other things. Ships do that. Other things do that. They have a very short-term temporary warming effect in the atmosphere if the sky is clear during the daytime in the summer. It's very localized, not a big impact globally, and it goes away in a couple of hours. Other things affect climate too, like clearing a forest warms the local air right under where the forest used to be. Building cities causes an urban heat island. We don't count any of that stuff either as a global climate change issue. So when we talk about flying, it's 1.8%. Sometimes there's confusion around that. Just stick to the real math, and it's about a little less than 2%. But in transportation, we can talk about all these things. We've got to tackle everything: aviation, cars, trucks, planes, boats, everything. And again, we can start by making the current mode of transportation more efficient, getting hybrid cars that still burn petrol, but they use less. More efficient trucks, more efficient aviation. Airplanes that fly, but airplanes today are about twice as fuel efficient as they were 20 years ago, but they could be even better. Ocean shipping could be even better too. But then we could shift to other ways of imagining transportation that don't rely on fossil fuels at all, like walking, bicycling, public transit, high-speed rail, or what we're doing today, telepresence and video conferencing. These are things that are alternative modes of transportation, essentially, and can reduce greenhouse gases as well. And then we can do things like electrify a lot of our vehicles. Cars and trains and trucks can be electrified. And if that electricity is made with renewables, then it can be totally carbon free. It's fantastic. Aircraft are going to be pretty hard to electrify large aircraft, those small ones could be. We're going to think of other solutions for that down the road. But right now, again, being more efficient, shifting to alternative ways of doing things, and electrification seem to be the most promising solutions to reducing greenhouse gases from the transport sector. Okay, now we got buildings. And buildings are pretty interesting because buildings directly emit about 6% of our greenhouse gases. That is what they emit from the building envelope itself: a furnace, a boiler, a hot water heater that's maybe burning natural gas or something like that, or refrigerants that are leaking out of a building. So, but buildings also use electricity. They're also where cars go. So sometimes you'll hear buildings kind of have a shadow footprint that's maybe as much as a third or even half of climate change in some places. Yeah, you can make that argument. But in the accounting schemes, we usually kind of look at where the building emitted directly versus indirectly at the power plant. So this is the direct building emissions, just to be clear. It's about 2-to-1 residential emissions to commercial building emissions. So of that 6%, 4 of it is residential and 2 is everything else. And one of the things we have to think about is we can make new green buildings that would be better than the old buildings we have. But for the most part, for the next 50 years, most of the buildings we'll see in the next 50 years have already been built. There are hundreds of millions of buildings on Earth, and we're gonna have to retrofit all of those as well as build everything new better than it was before. So a lot of the efficiency gains we're going to see is retrofitting buildings to be more efficient with the use of energy. Thermostats, building envelopes, low flow fixtures, maybe retrofitting to net zero buildings that generate electricity and use a lot less. They can shift the energy sources they use from, let's say, natural gas to electricity and using heat pumps, or using solar to heat the hot water instead of oil or hot water from natural gas. We also need to make sure that within buildings, the refrigerants we still use are not leaking out of a building air conditioning system or out of refrigeration and freezer systems. So we can find lots of solutions to buildings here too. Now, the other category, the remaining 10%, I'm not going to talk about that today, but there are solutions there as well, especially capping natural gas infrastructure, making sure they don't leak. Eventually, we need to phase out fracking and natural gas altogether. That's going to take a little while though. In the meantime, today, we should have done this years ago, we should plug all the leaks of natural gas pipelines and wells and everything to make sure what we call fugitive emissions, kind of unnecessary, unintentional emissions of leaking methane, don't get into the atmosphere, because that's so dumb. We should be able to stop that soon. So these are all the places we can reduce emissions and basically reduce sources. But over here, we can look at the sinks of carbon and other greenhouse gases besides carbon dioxide. And those are mainly on land and in the ocean. As I mentioned before, the land surfaces of the Earth, primarily forest, absorb about 1/4 of all the greenhouse gases going in the atmosphere, and oceans around 17%. And that leaves behind a little less than 60% of the total greenhouse gas emissions picture. On land, what's happening here is, so far, the sinks of greenhouse gases have primarily been in natural ecosystems, not agriculture. And they're primarily because of photosynthesis. Trees will do more photosynthesis, As the CO2 levels in the air increase, they can grow a little faster. They accumulate a little bit more biomass or wood, essentially, and they can add a little more carbon into the soils as soil organic matter or humus. And when we want to preserve these land-based sinks, we can help reduce the demand on clearing those forests by reducing food waste and changing our diets. We can protect ecosystems being cleared, but then we can put other land into play. This is what gets really interesting. Besides natural landscapes that we could take the pressure off of, we can turn to our farmlands and working landscapes and deploy these regenerative agricultural practices that can rebuild the soils and maybe even the biomass above, like in tree farms and agroforestry. We can restore those landscapes to be better and accumulate carbon in soils and vegetation. This is tremendously exciting, although unfortunately some groups are really overhyping how big these numbers could be. This is an important set of solutions, but it is not the solution. There was a recent report from the Rodale Institute, who I love. They do great work in organic farming, but they made a very reckless claim saying that regenerative agriculture could absorb all of our greenhouse gas emissions. That's absurdly not true, and it got a lot of pushback from scientists who work in this area. So we got to get our numbers right here. But despite that, regenerative agriculture is a great idea. It's good for farms, good for the environment, even besides climate change. And it's one of the many solutions we could use to combat climate change too. And we can also try to restore degraded lands, not just the working lands we have now, but the working lands we used and beat up. We can bring them back to health and restore them to maybe active production or some kind of ecosystem. So we put all these land sink solutions together. We have things that can be farming better on the left, protect the ecosystems in the middle, and maybe restoring those degraded lands to the right. Those would all be really helpful. Oceans also naturally absorb a lot of our greenhouse gases, primarily CO2. Oceans absorb greenhouse gases 3 different ways, it turns out. One is called a solubility pump. Pump just means kind of taking it out of the air and putting it into the water. The solubility pump is just CO2 chemically dissolving in water, just like a carbonated beverage, like a soda or beer or something like that. And so that's pretty exciting. But the problem is, as the oceans warm, their ability to hold CO2 actually goes down. So cold water can absorb more CO2 than warm water. So we don't expect that number to go up. If anything, it might go down slightly. The second way the oceans absorb CO2 is through what's called a carbonate pump. What happens here is CO2 is taken out of the water, usually by a living thing, like a shellfish, let's say oysters or clams, mussels, or by coral reefs. And what those organisms do is they take seawater and they take carbon out of it and calcium out of it and form calcium carbonate to make a shell, either in coral reefs or in shellfish. And those things hold carbon in those kind of rocks and shells for very long periods of time. That's pretty exciting too. The last area is so-called biological pump. That's where plants in the ocean, either kelp, kind of big leafy plants that float around in the water, or microscopic plants like phytoplankton and diatoms, they do photosynthesis and absorb CO2 into their biomass just through like a regular plant. And when they die, they can settle down on the ocean floor and stay there for long, long periods of time. That's what nature does. What we humans could do is figure out ways to maybe accelerate those 3 things, especially the biological pump, maybe with kelp farms, or the carbonate pump by growing more shellfish, maybe oyster farms, things like this. Those would be pretty interesting. Or accelerating the natural weathering of rocks. That's part of what's called the carbonate silicate cycle that buries carbon material down deep in kind of ocean sediments. So that's kind of an interesting idea too. We're working right now on a whole bunch of different ocean solutions and analyzing them. There are a few been proposed, but very few have been assessed independently. And later this year, early next year, we should be presenting some really cool ocean solutions and how big they might be. A third area, which you'll hear a lot about, but right now it's not really happening yet, just some prototypes and some interesting science experiments, are building machines that could take CO2 and other greenhouse gases out of the atmosphere and pull them out of the atmosphere for good, either to lock them up and sequester that carbon in maybe a geologic reservoir deep underground, pump it away forever, or better yet, I would love to pull greenhouse gases out of the air and make stuff with it. Maybe we could pull CO2 out of the air with a machine and make our plastics out of it. Why do we need to use oil? Leave the oil below ground, but if we need something like a plastic for like a heart valve or good Tupperware, I don't know, maybe we could pull it out of our pollution, out of the sky, and turn it into a useful product. That would be pretty cool. Or jet fuel. We're still going to fly jets in the future. Military and civil aviation will still be flying with some aviation fuel. But instead of using fossil fuels, why don't we mine the atmosphere, pull pollution out of the sky, and make it a jet fuel? We can do that today too, it turns out. We just haven't learned how to scale it and make it economical yet at large scales. But the technology is very close. So here are ways we can kind of absorb greenhouse gases through sinks on land and oceans and maybe with machines. So together, reducing the sources of pollution and enhancing the sinks of pollution can help us get to drawdown. But there's a third area I haven't mentioned yet. It turns out besides sources and sinks, we can also work across society. It turns out that a lot of things we do for other reasons that don't have anything to do with climate change, especially around fostering equality, turn out to have kind of a domino effect in helping us address climate change too. Specifically, when we help, well, for example, getting more access to healthcare and education for girls and young women around the world. As the parity in education and healthcare of women and men gets closer, women tend to have fewer children, but healthier children who are more likely to survive. Also, children may be later in life as they pursue other economic opportunities and get married or couple up later in life. So this slows down future population growth, which will also have some impact on climate change down the road. But it's without coercion. This isn't population control. Those two words should never be used in the same sentence again. Instead, this is helping to lift people up and provide opportunities, and then they can choose what they want to do with that. But what we find is with more access to education and healthcare, women make different choices that are healthier for them and their families and their communities, and maybe for the planet too. We also find that when we help indigenous communities help protect their landscapes, especially forest, that indigenous communities tend to manage forest in ways that absorb more carbon, are more productive, and are more biologically diverse than the counterpart landscapes elsewhere around them. So again, maybe we didn't do this for climate change, but fostering equality along genders, helping indigenous people protect their land. These are good things to do regardless of climate change, but they set up a whole bunch of other things that help us with climate as well, kind of a win-win. So when we put it all together, it's really clear there's no one solution to climate change. It's not just renewable energy. It's not just better farming. It's not just protecting forests, educating girls. Nope, nothing will solve climate change by itself. We got to do a lot of things. We got to do them all at once. So we can look at ways of reducing the sources of greenhouse gases in electricity, in food, industry, transportation, and buildings. I showed you some of those before. We can work with nature and support its sinks of carbon, especially right now we know how to do that on land, but we hope to grow the ocean solutions and maybe some of the engineered kind of machine-based solutions as well. And then of course, things we do for other reasons around education, healthcare, and fostering equality, those also can produce climate solutions as well, kind of indirectly. So when we add up all of those circles, which each represent a suite of solutions, it turns out we have enough already to address climate change. Let me show you. If I put together everything I just talked about and did all of them, we can actually change the future of our planet. Here's what would happen if we do nothing else. The red curve is kind of our best guess as what society would do over the coming decades based on our current kind of energy and agricultural technologies and policies. It's just a guess, but that's kind of the business as usual scenario. But we can do two, or many other things. For example, this yellow curve and this green curve show what we call kind of drawdown scenarios. These are where we deploy the scenario, the solutions, I should say, I showed you before, about 80 of them. If we deploy all 80 or so of those solutions, in scenario one, we're pretty aggressive about it. In scenario two, we're wildly aggressive about it. We find we can stop climate change around the mid-2040s at the earliest, and maybe by the late 2050s, early 2060s at the latest. And if we do that, it would stop the warming of our planet. Right now it's a little over 1 degree warmer, We could stop it at about 1.5 in the most aggressive scenario, or maybe up to 2 degrees in a more moderately aggressive scenario. If we don't do anything, we're headed to 3 or more, and that could be a big, big problem. So we do have right now enough solutions to do the job. As other technologies become available, we'll add them in. But right now, we should use what we have today and just get them out the door as fast as possible. No more waiting. We've waited far too long. Let's get moving. Well, of course, there are going to be people who say we shouldn't do this. They're going to say it's too expensive or whatever, whatever, whatever. No, that's a lie. It's not true at all. We've analyzed the economics of that and find, yes, upfront, you do have to spend some money. This is what economists will call a cost curve. Basically, on the horizontal axis, those are the solutions all stacked up, and they total the total amount of carbon they would avoid or take out of the atmosphere. The vertical axis shows what will it cost. If it's above the line, it means it costs some money. Below the line, it means you made some money. Well, initially, yeah, you get to pony up a little bit of money. It turns out about 20 to 30 trillion dollars. But if we do this and we do it over about 2 to 3 decades, we actually make between 90 and 150 trillion dollars back. This is incredible because we're going to save a lot of money. We'll make new revenues. And in fact, this is probably the biggest business opportunity in human history. So when people tell you it's not economical to address climate change, what they really mean is it's not very convenient for some very powerful people, especially in the fossil fuel industry and big agriculture. That's what they really mean. But for the rest of us, the other 7.5 billion of us, it's actually a pretty good day at the bank because we'll save money and make money, and everything we're doing here would make the world better. And by the way, this doesn't even count the damages climate change would cause if we don't do anything. And that could be uncalculable, trillions and trillions of dollars beyond this. So if somebody says it's not economical to address climate change, they're flat out wrong. It's not economical to ignore it. We have to pay attention to it. So every business leader and every capitalist in the world should be on the climate change solutions bandwagon because it's good for them too. So what have we learned? We've learned a lot here tonight. First of all, it is not too late to address climate change. Yes, the planet's 1 degree warmer than it should be. I wish we'd stopped it earlier. Scientists, we've all been talking to you about this for 30 to 40 years, really loud, but we waited and it got 1 degree warmer. But we can stop it from getting a lot worse. We can stop it at 1.5 to 2 degrees. That is entirely within reach. We can do it with solutions we have now. What we have to do is scale the technologies and solutions we have available today. Rather than waiting for the new tech, let's use what we have today and do it now. Actually, at Drawdown, we say now is better than new. Using today's technologies today is way more important than developing tomorrow's technology. Let's do both, but first scale what we have now. So I talked a lot about solutions. If we deploy those 80 things into the world, we can stop climate change and make the world better and make a lot of money for everybody in the process. That's great. So why isn't it happening? Well, what we need to do is not just find solutions. We have to look for the things that make solutions actually happen. We call these accelerators. They're basically the things that push solutions out into the world and grow them. So what do we need to do to get solutions to grow? Well, we got to change the rules. Those are policies, regulations, laws, how taxes are done, how incentives are made. We have to shift capital, basically move a lot of money from out of bad things like fossil fuels and bad agriculture into good things like renewable energy, regenerative agriculture, protecting nature, increasing equity around the world. This could be a huge transfer of capital, but it'll be good for us. We get to change the rules for business because markets are good at solving some problems, but if they aren't given the right kind of incentives and the right guardrails, they'll do things that are kind of crazy. But if we tell them, hey, destroying the planet isn't a good business model, maybe business could be helpful and adjust and do good things. Technology is important, but don't wait for it. We have enough now, but if we bring in more technology and fold it in as we go, that's a good idea too. And yes, behavior is important too. Our individual choices do matter, but just not going to be enough. What we need is policy and practice at all levels, including our own. Things like food waste, energy efficiency, a lot of that is within our own personal reach. Not everything is going to be something we can solve by ourselves, but we can help out. And so why don't we look at all levels of agency, from the personal to the kind of community to the business to the national level, to the international level, if we work together and use every kind of tool in our toolbox, we can make this happen. And we're going to be at it for a while. Solving climate change will not happen overnight. We got into this over a couple hundred years, especially the last few decades. It's going to take a little while to undo it. If we think about climate change solutions deployed over the next 3 decades, let's say, the first things I would do is deploy the things we know make money now, are simple, quick wins that work today, like energy efficiency. Let's make cars, let's make buildings, let's make industrial processes far more efficient. We know how to do that. We could lop off half the problem right there. Food waste, a third of the food, a third of the emissions, we can tackle that. Deforestation, it's not planting new trees, it's just stopping the burn down the ones you've got. We can tackle those today. Methane leaks from fracking, from wells, from pipelines. Let's plug the leaks, even as we start to undo natural gas over the long run. And then, I wouldn't have said this 5 or 10 years ago, but switching to renewables instead of fossil fuels actually makes money now. In fact, today's technologies for renewables, especially solar and wind, are cheaper than almost every other form of energy. So what we have here is what's called the kind of levelized cost of electricity. How much money does it take to make 1 megawatt hour? Utility scale solar, that is solar over a large farm, wind farms, are cheaper than gas, cheaper than coal, way cheaper than nuclear, and cheaper than peaking gas plants. So this is the obvious low cost alternative for energy. And that's what we're deploying. Over the next decade or two, now looking at over maybe not just a 10-year horizon, but a 20-year horizon, we've got to talk about infrastructure. We got to rebuild everything. We got to change the way all of our farms work. There are hundreds of millions of farms on the planet, and we need to change some of the ways they're doing things to be more regenerative and better for the environment. We have to remodel every building on Earth. Every furnace, every water heater, every hot boiler, everything will have to be removed and replaced. Also retrofits for energy efficiency, for better transportation, all of that needs to be done. Our transportation infrastructure needs to be updated as well. We can do more electrification. We have to have charging stations. We need more high-speed rail, more public transit, more video conferencing, better ways of getting around aviation, maybe more trains instead. All of that, we have a lot of work to do on these big infrastructure changes, and that's going to take a little while. And then over the next 3 decades, I'd say this is where we still need some very heroic new technologies to help kind of finish off the problem. For example, we need to find very credible new ways of making cement that's cost effective, that don't release CO2, or new kinds of refrigerants that can replace the fluorinated gases with something that will contribute to climate change, or carbon-free steel, maybe even carbon-negative steel. Is that possible? What about jet fuels? Can we make carbon neutral or carbon negative jet fuels? Absolutely we can. We just don't know how to do it cost effectively right now. But over the next 2 or 3 decades, we can do that. The sooner, the better. So to me, I actually look at climate change. Yes, it's a very serious and sometimes depressing problem. But if you start to go beyond that and you kind of process how kind of scary it is, and you get through that, you start to see it maybe as, hey, there are opportunities here to make the world better, not just for climate change, but for a lot of things. It turns out we get to reimagine the world and rebuild it all. And along the way, not only can we address climate change, we can address other environmental issues, certainly around biodiversity and water and forest and ocean health and all of that. We get to reimagine how we live, and things like equity and justice and community and resilience, all of these things that we value can also be improved. So I think climate change represents kind of a reboot opportunity for the planet, because we're heading off in some pretty strange directions right now. But if we're smart and we're clever and we have good hearts, we can maybe pull back and push ahead in a much better way and build a world we can be proud of. And all of this is possible and within our grasp. But we need something else too. I talked a lot about the science and technology, a little policy and capital and all that stuff, but we need something more than that to get there. And I personally think we need a different kind of leadership, one that articulates a bold vision of the future, a vision that we want, a vision of the world we'd like to live in. I, for one, would like to have leaders who not just give us scary bedtime stories about how everything is terrible and those people are to blame. That's what we're getting from a lot of our political leadership, at least in my country right now. What we need instead is a leader who doesn't just bully us and tell us who's to blame, but maybe leaders who inspire us, ask us to come together and build a world that we want. We've seen this a few times in history. Martin Luther King didn't go around America saying, I have a nightmare. He said he had a dream. He died for his dream, and we're not yet finished with it for sure, but we're inching slowly towards a dream he first really articulated to all of us. He invited all Americans and all the people of the world to join together in building a future where children were judged on their character, not on their skin color. And we still can achieve that dream. It's just going to take some more time, sadly. But other visions like that, let's go build a better world and let's join together to build it. That's what I think we need. Rather than telling us how terrible everything is and tearing us apart, tell us how good it could be by coming together. And that's what I ask of you next, is that you can help with that. Maybe we don't just rely on our elected leaders. Let's look at leadership in the mirror. All of you are leaders. All of you can change the communities around you and the people you interact with on a daily basis. So learn more about climate solutions, not just the problems, but what can we do about it? How can this help us? How can it make a better world for all of us? And share that with people you know and care about. That would be so great. I hope that we can be a resource for you along that journey. So can some others. But we stand by to be a free kind of public resource. We're nonpartisan, we're non-commercial, we're grounded in science. So I hope we can be helpful to you. Just come to drawdown.org and follow us on social media and keep in touch with what we're up to, and we'd like to help you with that. But most of all, what I want to ask you all to do as we close up here is to remember the future is not written yet. Don't believe anybody who tells you what the future is going to be, because we don't know. We get to build it. Tomorrow isn't done yet. We haven't even finished today. The future is up for grabs, and it belongs to those of you who are going to take that risk and accept the responsibility of consciously creating a future that you want. So with that, I'm going to just say thank you, and I'm going to turn it back over to Elizabeth, who's going to look at the Q&A box and maybe take some of your questions, and we'll have some conversation, and we'll stay put here for maybe another 15, 20 minutes. So
Perfect.
Thanks so much.
Yeah, thanks so much, John, and thanks everybody for taking the time out to learn about climate solutions. We, for those of you who haven't had a chance to put your question in the Q&A box, I encourage you to do that. We've got lots of great questions, and to those of you who already put it in there, I didn't dismiss any of them. I'll make sure I have another sheet where I'm combining them. So we'll get through as many as we can, and go ahead and keep putting them in the Q&A box while we're reading them out. So let's start, John, with plastics. We had a couple of questions about where plastics fit when we think about climate solutions.
Yeah, well, plastics are one of the many things that industry makes that can contribute to climate change. So there's the energy used in making plastics, of course, and then the use of plastics themselves and their disposal. It turns out there are little sources of greenhouse gases all along the way, and they add up to about 1.5% of what causes climate change. That may sound small, but it isn't. It turns out there are about 100 things that are each about 1% that cause climate change. We got to deal with them all. So 1% here, 1% there, we got to tackle every single one of them. So yeah, plastics are, not a top of the list kind of issue for solving climate change, but it's on there. And what I like is if we can rethink plastics, we solve a bunch of other problems at the same time, especially marine debris and coastal pollution, habitat destruction. And goodness knows what these kind of microplastics are getting into, like food webs, into our food supplies, into the environment. We have no idea what that's going to do and other things down the road. So I think the single-use plastic kind of thing is kind of crazy. Yeah, and somebody's mentioning a report. Yes, the Sealy 2019 report is very speculative. I'm not sure I buy that. Yeah, I'm waiting for more science to, there's somebody in the chat box just added, there was a report recently said microplastics might harm phytoplankton's ability to do carbon uptake. That's not actually been seen in the open ocean. That's just a laboratory kind of study. I'm not sure that's really at scale yet, but it might be. But that's more speculative. I wouldn't buy that just yet and get too worried, but it's up there. But microplastics are a big issue for so many reasons. What's kind of amazing about climate change is when we solve climate problem, if we do it right, we solve like 5 other problems at the same time. And personally, I love some plastics. if I need a new heart valve, hell yeah, I want a really good plastic that will never biodegrade. I want that stuff to be bulletproof. Or, something that, I don't know, I want a new kayak or whatever. Great, make it out, fantastic. But these disposable plastics we use every day for things like water and then throw away or pretend to recycle it when we really don't for the most part, that's crazy. So we can probably get rid of a lot of single-use plastics just by being smarter about packaging, using things that are truly recycled, like aluminum instead of plastic. That would be far better. Or just rethink what we do with things like water, especially. That's fine. And let's use a little bit of plastic for where it actually is super useful and long-lived kind of materials where we need something that's moldable and reusable, and make sure that that stuff's truly recycled later, which it certainly could be. So I think we can get a lot smarter about plastic. We could have for years, and we just haven't done it yet.
Thanks, John, and thanks for the questions, everybody. John, let's stay in the ocean for a minute. We talked about the ocean for a second, and there's a question about ocean sinks and whether or not we've looked at acidification and warming and the carbonate pump. What would you like to say about that?
Yeah, that's really worrying. I'm glad somebody asked about that. It turns out that, yeah, remember that I told you there are 3 ways the oceans take up carbon, the so-called solubility pump. That one, as the water gets warmer, the ability of CO2 to dissolve in water actually goes down. That's why, like, if you have a beer and it gets warm out and you open it up, it fizzes everywhere because it can't hold the extra CO2. So that's kind of a problem. That's one way a warming ocean can have a smaller sink, is just solubility. Second, what this question refers to in the carbonate pump, which is when organisms like shellfish, crabs, and lobsters and things like this, as well as coral animals, are making their exoskeletons, their shells and their coral bodies in a more acidic ocean. As CO2 is dissolving in seawater, it becomes slightly more acidic or less alkaline. Those organisms don't do as well. They don't produce as much shells, and the shells get deformed and the organisms don't seem to thrive. So unfortunately, in a more acidic and perhaps warmer ocean, the carbonate pump might also be a little bit in trouble. The last one, the biological pump, which is where, like, it's the phytoplankton, diatoms, and things like kelp, kind of macrophytes they're called, like big plants in the ocean. How they respond to a warmer and more acidic ocean is not yet totally clear to me anyway, but we're seeing some big losses of kelp forest off the California coast lately. But that might have to do with the warming and how it affects some of the food webs and very complex food webs between things like otters and sea urchins and everything else that kind of keep the kelp healthy. So I don't know if that's a long-term effect or not, but it's quite worrying. So we're seeing kind of a slow erosion of the 3 things that take carbon out of the atmosphere into the oceans. None of them are looking pretty good right now. So that's, again, where helping to kind of restore ocean health and do whatever we can to help out the oceans would be a good idea right now. One thing I would do is more on the coastal side, kind of near where we live, is things like protecting things like mangroves and coastal ecosystems and coral reefs and oyster beds, because it's closer to where we have a realm of influence. But also those ecosystems sequester a lot of carbon, and they also protect our shorelines from big storms, which are becoming more and more frequent. So it's a little bit of a win-win there. So preserving wetlands, mangroves, and other coastal ecosystems are a really good idea. That's something we can do.
Great, thank you for the question, and thanks, John, for the answer. And I'll also point folks to the Drawdown Review, which is the latest publication we have on our website, where we write a lot about these co-benefits that John's been talking about, right? Where climate solutions are rarely just solutions that are good for the climate, but are actually good for many, many things. So that's a free download. It's our latest publication, a big update from the 2017 book. So for those of you who haven't checked it out yet, please check it out on our website. I'm also, John, there's a couple questions about these posters that I have in my background, which is kind of a tease. And so I was just going to let folks know that to please sign up for our newsletter. As soon as we have a way to get those to folks, we'll let you know. We're still figuring that out. So sign up on our newsletter on drawdown.org, and we will let you know.
Well, another thing too, you might want to mention, Elizabeth, is we're going to be moving to making everything freely available on the web. The early version of Drawdown, we wrote a book that was a commercial book, and you had to go buy it or borrow it from a library, which is great. But we're moving to everything being totally open source and free. So the Drawdown Review, which is like a little book, about 100 pages or so, it's free. It's a PDF. You can just download it and give it away as much as you want. So that's free. The posters Elizabeth mentioned, we'll have digital versions of those for free down the road where you can download a PDF and look at it every day you want, put it on your monitor, on your phone. Be a really great phone cover, I think would be awesome. Or you can hit print maybe locally and print it at a local print shop if you want to. We may have ways where we can mail a few out ourselves, but that gets to be kind of expensive and defeats the purpose of being kind of open source like that. But also we're gonna have like images and some slide materials for people who wanna give educational and kind of community-based presentations around climate solutions. Elizabeth, can you mention kind of where those can be found right now? We have some of those available now.
I will put a link into the chat box for everybody. And there's a couple of graphics that John used tonight that you're able to freely use as you talk about climate solutions. And that's actually one great solution that we haven't calculated the carbon dioxide equivalent emissions reduced, but we do know that talking about climate is a great step for all of us to take when we are moving towards drawdown.
Yeah, and we'll, as I mentioned at the very beginning, we're going to do a more professional recorded version of a talk like this. It'll actually go into more depth, but the nice thing is it won't be just me talking for all the whole time. It'll be cut into shorter little episodes and then little breaks in between. We'll hear from other climate experts around the world. We're a very diverse set of really cool experts internationally from very different backgrounds. So it should be really great, and that should be available, I'm hoping, the end of the year, early next year. We'll see how long it takes to get it edited down, but we're filming it next week. And there'll be some other things as well available, and soon a new series called the Drawdown Primers, which would be kind of like introductory briefing books to help people understand a particular issue around climate solutions. Our first one is going to be on regenerative agriculture because it's so promising, it's so important, it's such a great idea, but there are a lot of confusing claims being made that kind of make it people really, well, just confused. So we're trying to sort it all out and tell you what we know and what we don't know. That'll be the first one. We'll probably do more later, and those will be free as well.
There was actually a question that came through about, well, kind of two parts. One was about regenerative grazing and kind of your thoughts on that. And another was on synthetic food and whether or not we should shift off of the land and into synthetic food. So I don't know if you want to tackle both of those at once or separate those out.
Sure. I mean, so regenerative grazing is the idea that if we, right now, how we graze livestock around the world can be pretty messy sometimes. But there are a lot of different techniques, sometimes under the called multi-paddock grazing, or sometimes called holistic grazing, where you kind of have a concentrated kind of group of animals in a small area for a while, then you move them around and move them around and move them around. It seems to have the effect of regenerating kind of the natural cycles of plants and soil organisms that probably mimics what grazing animals in nature used to do as they moved around and migrated, like buffalo or in the Serengeti or whatever. And when that happens, it seems to kind of kickstart a whole lot of interesting soil activity that builds up soil organic matter and more productivity and more closed nutrient cycles. It's really a great idea. So I'm a big fan of regenerative grazing. But there are two problems with it. One is some of the claims about how big it could be as a climate solution are preposterous. They cannot possibly be true. So dial down the expectations about how big a climate solution is. Even if it could do 5% of our climate problem, it'd be a miracle, and as much as like solar panels could do. That'd be great. I'd love to have that. But people claim it's all of the climate solution we need is just, that's nonsense. It doesn't physically, totally breaks the laws of physics. It can't possibly be true. But we should do it anyway. It's great stuff. It will definitely help with climate change and so on. But cattle still burp methane no matter what we do. And even if the soils, build up carbon, they eventually slow down and don't build up as much year over year. And the cattle keep burping methane. So when I think about kind of cattle and climate solutions, I think let's eat less beef. Let's waste none of it because it's so precious to grow and so environmentally intensive. Let's eat less, waste none, and grow it better on grass. That would be a good kind of triple win, if you will. We can eat a little less beef, especially in some rich countries like the US, not zero, but less, and then be much more mindful of eating, making sure the waste is very, very low. And what we do eat, let's grow it in the most regenerative way possible, which has a lot of benefits to ecosystems, particularly to watersheds and to biodiversity. And yes, it's a good little climate solution as well. But be wary of anybody who comes along and says, I have the solution to climate change, because they're trying to sell you something and it isn't going to work. There's not one solution, there's going to be hundreds. The next question is around what? Synthetic meat or synthetic food. I'm not sure what you mean by synthetic. There are a couple, let's say meat. That's gotten very sexy lately. They're kind of artificial meat. There are two ways to do that. One is to take current plant material, like, I don't know, soybeans, chickpeas, lentils, potatoes, other things that are rich in nutrients, kind of mash them up, add some stuff, and make them taste like a hamburger. That's the approach that like Impossible Foods and Beyond Meat and those folks have done. And that's very popular. I happen to like them pretty well. Some people will argue, though, that the way those plants are grown wasn't very environmentally friendly either. They're using a lot of sprays and chemical agriculture. And so is this stuff really healthy? Is it really better for the environment and so on? I would still say yes, it is, but it could go even farther and be done in an even better way than that. But overall, just going from animal-based protein to plant-based protein is just an order of magnitude less land, less water, less greenhouse gases. There's just no other arithmetic that works. But I think they could make it even better than that. Another way to make animal protein-like material without grazing animals or something like this is to actually synthetically make animal meat. This is like artificial meat itself, basically using like the stem cells of an animal to grow muscle tissue in a laboratory or in a big vat and grow a steak, to grow, I don't know, a scallop or a crab sandwich or whatever, to literally grow that in a laboratory setting from the kind of original stem cells of those animals to just make muscle. There have been a few kind of lab experiments to show that and a few pilots. Is this economical? I doubt it. What are you going to feed those muscle cells? Because those are still animal cells. They still have to eat something. What are we feeding them? That's the same thing about insects too. Some people think insects are a great solution to climate change. Like, well, the insects have got to eat too. They don't grow from air, they grow from plants. And they're about as efficient of converting plants into animal protein as a chicken. So basically for me, I would go with a more low-tech solution. Can we cut down, especially in like my country, the United States, we eat just too much meat. Can we cut it down in half? It'd still be more than most countries in the world. And our doctors are telling us we'd probably be better off. And let's make sure what we still eat in meat, those of us who still might eat some meat, let's not waste any of it. Let's make sure we be very mindful of how precious this stuff is and how we should be very, very careful with it. And then let's use like protein from plants to fill in the gap, like lentils, chickpeas. There are a lot of delicious, wonderful plant-based proteins that most of us don't know how to cook very well yet. We could learn a lot from other cultures around the world about really great plant-based protein meals and dishes that are delightful. So I'm excited about the great food opportunities we have. We're gonna have some great new cuisines, lots of yummy things to eat, and just to be rethinking our food a little bit. It doesn't require everyone become vegan. If you want to, great. But if half of us just dialed it down, that would help a lot too. So there's a lot of things we can do. But the heroic technologies of 3D printed meat and stuff, I'm like, yeah, fine. But you know what? I could do without the hamburger every day, kind of, like I'd rather just pass on it altogether and eat maybe I'll have a falafel. So, but that's just me. Everybody needs to make their own choices, and wagging fingers and yelling at people what they should eat doesn't usually work as a persuasive technique. But maybe working with people to introduce more healthy, tasty, yummy, interesting dishes that are fun, that could be cool too. So let's do it all and see what works. Hey, falafel, we'll get all the falafel.
Yeah, that's great. It's almost dinner time for some of us in some parts of the world. And lots of other time, breakfast and lunch, and we got some thank you from folks in New Zealand for giving this presentation at a reasonable hour. So thanks for doing that, John. A couple more questions before we need to sign off, everybody. John, people are wondering where they can learn more about the technical aspects of our research. Where would you like to point them?
Yeah, on our website, we do provide some kind of more technical like PDFs that kind of begin to outline some of the more technical aspects of our work. What we do, for the rest of you who probably don't want to read all the technical manuals, what we do is we do what we call like a meta-analysis. We go and look at all of the other scientific papers that are published around like how effective could solar be in reducing greenhouse gas emissions. We look at hundreds and hundreds of these and kind of find the average, if you will. And then we look at like, what do the economists say about the cost? So we do what's kind of a study of all the studies. So as more research is done, our numbers can get more and more refined, and they don't depend on any one point of view. They kind of synthesize all of them. They do this in medicine too and other things. So that's kind of the gist of what we do. But then we do all of these solutions in parallel and make sure that they don't, when they interact with each other, we take into account that they, like, when you use more electricity in electric cars, we've got to amp up the renewables to make up the difference. Or, that we have the same amount of land on Earth that is partly for food, partly for nature, and partly for carbon. We got to make sure it all adds up. So that's kind of how we do that. There are some technical manuals there, which is really cool. And hopefully that can help.
Great. So check out drawdown.org, everybody. Okay, John, we've got a couple more minutes. I wanted some great questions about venture capital, private equity firms, and whether or not there's a funnel from Drawdown and kind of the solutions we're working on to, for folks to invest in these kinds of climate solutions. What would you recommend there?
Yeah. So one of the ways the world changes, not the only way, but one of the way the world changes is by moving capital. And so investors and businesses have to be at the table too, along with policymakers and activists and communities and all of us. Not one or the other, it's all of them, I think. So we want to make sure we can be a resource to some business leaders and to investors who really care about these issues. We're very picky who we work with. But we don't have any direct, zero financial relationship with any of them because we feel that might compromise our objectivity. So we work with some companies, we give away a lot of things to investment firms and things like that. We're happy to talk to them, but we don't pick one and have like a financial relationship with one. That would just be inappropriate. So we work with philanthropists, donors, we work with impact investors, people looking to make some money, but also make a difference in the world at the same time, which is really cool. Love that. Sometimes private equity and venture capital too, though those are the kind of least patient versions of capital. So we're not quite as interested in that, but it's important too, especially as new tech needs investment. So absolutely happy to help there too. And we work with businesses who really want to elevate their climate ambitions to really meaningful change, not just kind of fig leaf stuff that makes them look good. We want to work with the companies that really want to do good, not just in their own business, but for the larger world. And so we're starting to pilot some work like that too. And it's hard, we got to figure out how to maintain our objectivity and all these kinds of things with all these different interests. But I think we need to do that and find a way to share what we know with everybody in different sectors, policymakers and activists, community organizers, you and me, and business leaders, investors, all the above.
All right, John, here's, folks, thank you so much for the questions. We've got time just for one more, and I'm going to throw this one at you, John. The question is, what are some of the most creative or inspiring grassroots or community-based solutions that you've seen?
Oh, wow. There's so many. But I guess I'll talk about a genre of them. I really love when communities work together to build social capital as well as things that help their neighbors and help the environment. For example, it's only a small part of the equation. We need governments and businesses to do the big share of it, but we at home can do a little bit too around climate change, like insulating our attics, changing our diets, growing a little food on our own, all these things we could do better. But it's kind of hard as an individual, just in your own apartment, your own home, to like redo all your lighting or to, figure out how to insulate your walls or redo your windows. That's a lot of work and a lot of things to learn. Why not do it as a neighborhood? Why not do it as a community? Could there be maybe some incentives from the city government or the local utilities to help people do that? Or in some towns I've lived in, actually Elizabeth and I both lived in a town that had these things called eco teams, which I thought were lovely. People would get together over a meal, about like 10 to 15 families would get together over a kind of a potluck dinner, get to know each other and become friends. But we also would go home to home to home, taking turns, like, hey, we're all going to get together and insulate Elizabeth's attic this weekend. And because she wouldn't want to do it by herself, what a drag. But if it's like a kind of a party and we're having fun doing it, having fun saving the planet, that's pretty cool. So I love kind of things that tap into our kind of innate human social desire to build community, which we need so much more of in the world today, I feel. Can we do that and shape things like, how do we improve our green spaces? How do we advocate for maybe different policies or, better, and especially communities that have been so overlooked for so long? How can we help not just the wealthy and the privileged, But maybe maybe the privileged communities can get together and say, now let's go to neighborhoods where people haven't had voices, haven't had power, haven't been listened to. How can we help our other neighbors be more powerful in the community as well and improve their lot as well? That would be great. So I can't think of just one example, but I would love to see many, many more of these. And you know, one thing I'll just leave with is like, we should not abdicate our future to the politicians and the business leaders and say, you know, yeah, they've got a lot of work to do and they have a lot of responsibility and a lot of culpability here. Like they have done not nearly enough to help on climate change. And so we should hold them accountable. But we should hold ourselves accountable too, a little bit. It isn't our fault, isn't our blame, you know, it isn't all on us, but we can do a little too. So I want to see all of us kind of see, what can we do from a positive point of view? Not who do we blame, but what can we do? And we all have different things we can do, whether it's local community stuff, voting, doing things at the community level, family level, sharing things with others. We have all these incredible tools at our disposal today to change the world around us. And instead of tearing each other down, let's build a better world with it. And I think we can all do that. And working at the community level is one that I think is a particularly good thing we can all do. It's not just your light bulb, it's like changing your community. That would be good too. So let's see what we can do.
Thank you so much, John. What a great note to end on, to, leave the webinar and think about ways that we can lift up everyone in our communities and work towards climate solutions. So with that, everyone, thank you so much for tuning in. Please visit us at drawdown.org and on all of the social channels. We look forward to seeing all of the solutions that we all put in place around the world. Thanks so much, everybody. Take care.
Thank you all.